Hey folks. All right, so today what we're going to do is work on a little demonstration of building a schematic and setting up a board, a circuit board using CAD Soft Eagle, right? And the last video I made was one where we made a footprint for an electronic component for a humidity sensor, and so we're gonna show you how to write a schematic incorporating that footprint. And once we have all of our pieces in the schematic, we're going to connect them up with wires. Then we're going to go to board view and we're going to lay out the board and we're going to route the wires using the CAD software in Eagle. And once we have that done, we'll run the CAM program, Computer Associated Manufacturing, and that'll create Gerber files, right? One thing I forgot to do while I was recording this was to run a design rules check. And that's an important thing to do. Make sure that all of the design that you set up in the schematic is actually faithfully followed and you don't have any problems. Okay, so I forgot to do that while I was recording this, but yeah, do it in the future, okay? All right, so here is the video. Okay, so last time we generated our footprint and our little part for this project, and now we wanted to do a schematic, make a schematic. So what we want to do is we go into File and New, and we'll generate a new schematic, but I've already set that up, so let's just get into it. We're going to add the part that we just made, and we have to then find it, and like I said, it's in AJAC library, that's the library, and it's this HTU31D thing. You'll recognize, well, you'll kind of recognize it. I made the pins a little longer because I decided I wanted to be able to get hold of them with my soldering iron. Okay, so we're going to just put one there, and then we're going to go back and hit that thing. I want to have some other things on there, so let's go into Add Part again. And now let's put some headers in there. So we want headers. We're going to type that into the search bar. And I want to go into the SparkFun connectors, and I want to have a 4-point connector, and I want this Molex 1.4. All right, yeah, it's the 1 times 4. And let's just hit that, and I want to have two of them. I want to have one on each side of the board. I also want to have two pin connectors, because that's what I'm going to use to connect my what's it called, what I'm going to use for my solid state relay. Okay, so let's find the Molex 1x2. That looks good, and we'll put two of them down there. Okay, so now we are going to go to Net, and we're going to put these things together. So I want this first two headers to connect. So one will be like for input and the other one will be like for output. And we need to have a ground for all of these. So I'm going to connect the number 1 pin for the grounds for each of those to the ground. This guy here is just going to go from one header to the next. So that part is done. We have this thing over here that's got a ground, and we're going to hook that up, and that's what we got. Let's see, we're going to have a plus 3.3 volts on both of these, and that's what's going to be voltage DD. So let's run that net. And let's see, what else we got? We have the serial, the data pin for the inputting the data. Those, I wish I hadn't done it that way, but that's how you do it. You learn these things. Anyway, in addition to the serial data pin, we also have the clock pin. All right. Let's see. The rest of these things, these two, the add and the address and the reset pin, they're both going to be just pulled high. And we're going to pull them high with a resistor, a pull-up resistor. Okay, so we need to put the resistors in there. Resistor, I'm in search and I'm going to hit OK. And just the RCL or RCI, I'm not sure what that is. That's the library we go into. And I want to use 603 resistors, okay? 603, they're big enough to get hold of, and you can deal with them with a soldering iron, and yeah, I just like that size. Okay, so we're going to put pull-up resistors there. We're going to put pull-up resistors on our what is that called? Our different inputs, the I2C inputs. Go back, click the net again. We're going to hook those all to this VCC or VDD. I don't know why they call them one thing versus the other, but they do. Anyway, going to hook all these pull-up resistors to the 3.3 volt input. Okay. And that should be good for that. The data sheet also suggests having a capacitor in here. So let's add a capacitor. All right. Capacitor. And that will come out of the same library. I like the European symbol. I don't know why. Anyway, let's find the 602, 603 input capacitor. Okay. And that goes between the ground and the high voltage. High being only 3.3, so not a very high voltage. All right, so that is the circuit. If you're wondering where I got this suggested circuit, it came off of the data sheet. I could probably find that relatively easy, but that's a little time we don't need to spend. Now what we're going to do is we're going to go to the board view, and the board view basically has all of the parts that we need to put on, but they're just kind of hanging out in the middle of nowhere, okay? So we're going to put these things onto the board. And I'd also like to put on a couple of mounting holes, and I forgot to do that. So let's go back to this thing, back to the schematic. And anytime you add something, you need to put it in the wire pads. There we go. Holes, mount hole. Okay, I'll put in a couple of these 3-0 mount holes. 1, 2. And now we go back to the board, and we're going to select them with the move button. And just put them on the board for now. Okay, let's rotate these suckers. I want them to be vertical for some unknown reason. Okay. And we can move this piece up to here. Looks good. This one up to there. Good enough. And we're going to get all this into a smaller area. And then what we're going to do is zoom selected. We'll just say we can put it in there. All right, so let's get this thing hooked up. First of all, let's get this one over to here. That goes to that. All right, let's rotate that thing. There's a little rotate button there. We're going to rotate that 3 times and Going to get another one of these resistors and figure out where it goes. Or maybe that's a capacitor. There's only one capacitor, so I don't know. What I want to do, I want to get this one. That's the one I want. And it's the one I want because I know where this one I want it to go. There we go. Okay, so let's now, what we need to do is click on this route air wire button and start routing our wires. Okay, so this goes to there, and these yellow wires, those are things that need to be connected. So we hook up all of our 3.3 volt guys. Let's see, let's hook up that one. And this one, and what are we going to do? Let's connect this to that, kind of come out a little bit, and then down. All right, this goes to there. This one goes to there. That goes to there. And pretty soon what you're going to find is that you're kind of stuck because you can't get from where you need to go to where you want to be. And what you're going to do, we need to get this connected to over here. And in order to do that, we're going to make trouble for ourselves. What we want to do is go down to the bottom layer. And what we're going to make this go from here to there on the bottom layer. So that wire is on the bottom layer. Okay, so that means that we can run some of this other stuff on the top layer still. Does this thing go where it needs to be? I guess it's done. Oh shoot, hit the wrong button. Yeah. Okay, now we can go up to here. All right, so we are getting there. This guy here is that's a what's it called? The ground, thermal ground. All right. Why isn't that one connected? Number 2 pin. Something's wrong with that. So let's go back to that. Oh, that is not connected. Ooh, need to connect. Number 2, boom, goes to, looks like that, doesn't it? Okay, now we should be able to connect that. Yes. Okay, now routing. Oh, that's got to go underneath. All righty. Let's see, we can't get to there. That's what I was telling you about earlier. What do we need to do? What do we need to do? What do we need to do? I think what we're going to do is rip that one up. So this button over here allows you to take these things off. Okay. And now we can go from there. All right. To there. And we're going to go on the bottom side from here. And now, you know what? Let's attach it there. So now I'm going to go back to the top side. And why didn't it go to the top? A lot of times, I don't know what goes on with these things, but what are you going to do? All right, now this, now we are ready for, let's see, something from here needs to go across that. What the hell's it doing? All right. Okay, and I have not connected any of the grounds yet. Let's put these guys, whoops, what the hell, I hit the wrong freaking button all the time. And what you'd like to do is to make your circuit boards as small as practical. And the reason is because, yeah, you pay for it you pay for having these things manufactured by the inch, by the square inch. Why is it not doing that? Okay, so let's see here. Now what we want to do is create a couple of ground planes, and you do that with this polygon tool. You know what, let's zoom in a little bit. Okay, damn it. Okay, polygon tool. What we're going to do is make a square. Doesn't have to be a square, but a rectangle. Doesn't have to be a rectangle, but that's the way we're going to do it right now. Okay, and we're going to give this one the name GND. That's the ground. Okay, and we have to name this other thing ground as well. And you do that with the naming tool. In the naming tool, it says R2, right? So we're going to click on that air wire there. We're going to call that one ground, GND. Okay, and you can see that lit up most of the top in red, okay? So all that red stuff is one big ground plane. And we're going to do the same thing, but we're going to do it on the bottom side now. Okay, and I guess we don't need to go out that far. We can do it there. Okay, and whatever, we're just going to do it like this. And once again, we're going to call that one ground. Okay, now we're going to go up here, and under tools there's something called rat's nest. And now the blue plane is a ground plane as well. Okay, so we don't need to have our outline be this big. Dang, I hit the wrong tool again. I keep doing that. And we are going to make it smaller. So we're paying for less circuit board when we purchase this. Okay, let's see here. What do we want to do next? We want to go, let's go back to the top layer. And, you know, I've messed around with this stuff so much that you're not seeing it the way that it would show up normally. Usually you have things like the names and the values of all of your resistors and capacitors and stuff. And that just makes me nuts when that comes up on a printed circuit board. So we're going to cut that off. The names and the values we cut off. And what I'm going to do is, let's put some text on this. Where's the text tool? There it is. And the text I'm going to put in there is going to be, let's see, ground space. What's the next one? I believe it is SCK clock. And then what is this one? This is serial data. I don't know what the S stands for actually. And then V3_3. All right, so that's going to be the text that I label this thing with. And it's not going to be on the top layer. It's going to be on a layer, let's call that layer top document, TDoc. There it is, TDoc 51. Okay, and I'm going to put that right there, and then I'm going to turn it. Where'd the turn button? There it is. Okay, so, and it's also important that you get the right size for this lettering. Otherwise, it's going to be too big or too small. And that tells you which of these pins goes with which of you know, what each one of them does. The other thing I want to do, I want to copy that. So there's the copy thing. Copy. And we're going to put that down here. And then we're going to change the text. And we're just going to have ground and signal. SIG, let's say. Okay, that looks good. All right, so that tells us what these two holes are going to do, pins. That tells us what these are going to do, and I think we are good there. All right, so we have now got our board designed, and we are ready to get it manufactured. So let's save that thing. Save as humidity sensor. We're going to call that humidity sensor 2. All right. And now what we want to do is develop something called Gerber files. All right. So we go into File, CAM Processor. Okay. So that's going to generate our or whatever it's called. We want to have our Gerbers. We want we want what? We want to change the silk screen top, because this has all that stuff in it that I told you I didn't want. We're going to get rid of those. How do we get rid of those? You got to hit the edit button. Okay, top place, no. Top names. Oh, top place we do want. Top names we do not want. We want to get that T document on there. Okay. And let's see what that looks like. Yeah, that's got our stuff on there. It shows us where our guys are going to be. And that all looks good. So let's hit the process job button. Okay, let's take a look at the folder. Okay, there's a CAM outputs there. All right, Gerber files. That's all from today. Looks good. Let's go back to that. Now what we want to do is we want to set up our drills, right? We're going to process that. Oh, I don't know what's going on. Apparently it did. Okay, so CAM outputs. Drill files. Drill 1_16 XLN, and XLN is the type of file that the drill file is. Now let's take a look at this and see if there's an XLN file in there, because I can't imagine why it would be. All right, now what we need to do is, we need another one of these things. Oh, we got 2 of them. Okay, so what we want to do is go into the drill file and move that into the Gerber file. Then we want to just select all these files, and we want to move to, is that what we want to do? No, we want to right click and send to compressed zip folder. There we go. And doesn't need to have that name. We're going to call this one humidity sensor. Okay, let's see what's in there. Damn it, well, let's screw that. All right, so what we're going to do now is go to our website. Let's open another. We only got like 15,000 of these things open. And this is OSHPark.com. Okay. And OSH Park is a company that makes these things for me. Okay, we're going to browse for files, and it's in projects. Okay, go into projects, find our Gerber files, and upload the humidity sensor. It takes us a little bit of time, but we got time, right? Okay, so what you see here is what you're going to get once we order this thing, okay? Here is our footprint for our humidity sensor. It tells us where the pin number 1 is. I put that on there just because I wanted to be able to find it, right? Everything's looking good. 2-layer board, which is just a little under a square inch, costs about $4.70. It's going to cost me, oh gosh, well, we're not going to worry about what the cost is. Anyway, this is all right. Looking good. Continue. Board top, board bottom, drills, top layer, silk screen, bottom outline, bottom solder mask, bottom layer, top solder mask. Looks good. Let's order this thing. It's only $5, right? All right. Looking good. Checking out. Check me out. Okay, I hope you have learned something from this, and I hope it helps you.